You may already know that I'm a little strange. I actually enjoy filing, even though I've always wanted a die filer which will help efficiency, but it would also help in keeping the file perpendicular to the workpiece and increase accuracy. While looking for inspiration, I kept falling on this 100-year-old Hartford die filer, so I modelled something very similar in Shaper 3D. I won't be building it on my own though. I'll be getting some help from my mates Corin and Keith. You may remember Corin from when we built the kayaks together, and here's some examples of Keith's work as a world-renowned knife maker. Anyway, let's get into it, and the first thing we'll make is the base. I want the whole thing to have a bit of weight to it so it doesn't shake around all over the place, and that's why we're using this cast dumbbell weight. We'll start by truing up one side and then we can flip it over in the chuck where we'll get a better hold in the jaws. Casting the body of the die filer would be the best way, and casting is something that I definitely plan on trying out, but at the moment I'm not set up for it, so instead we'll fabricate it using bits of old castings and steel. The cast iron chips or dust make a real mess of the lathe. I did order some way covers, but they didn't arrive in time. Just after starting, the way covers came in the post, so we fitted them temporarily with magnets. I will fit them properly later on. Corin and Keith were visiting this week and we wanted to make a project. We had no real plan, but when I told them about upcoming projects, they jumped at this one. One side done, now for the other. This one will be the top and have a bit more shape to it. First we'll bore out the centre, which the next piece of the body will be made to fit into. It's going to be a small die filer, but hopefully it'll be a very practical and usable machine. The main thing I want is variable speed and that the whole thing runs smoothly and not too fast. It may be surprising what we plan to power it with, but I'll save that for later in the video. There's quite a few parts to the whole project, which to get done in the 3 or 4 days that we had together, we just had to get on and make the parts where we could. So I'm showing them in an order that makes sense and not exactly when they were made. There was a lot going on. Corin and Keith did a fair bit of the work with me doing some and helping out here and there and running around filming the whole process. The template was just a rough guide, but we turned it down to something close to it. There was a lot of mess that needed cleaning up before moving on to the next part, which will also be turned on the lathe. The cast iron dust is not good for the ways, it can wear them out and it gets everywhere. The next part is steel and we'll turn that to fit into the base. I'm not sure what type of steel it is, but it is free machining and it's an offcut from a local CNC workshop. Next we'll turn down a taper to add a bit of interest and make it a more pleasing shape, but first we'll face off what will become the top surface. While Corin was turning these parts, Keith was working on the main upright, which was cut from a sheet of 16mm thick mild steel plate. We'll attach a template using thin CA glue, and as I've mentioned in a few videos now, I'm using Bondi Bond for all my CA glue tasks. It's a product that I've been testing for a while and I wanted to let you know that we will be launching it very soon. If you'd like to get on the waitlist, there's a link in the description where you'll get pre-launch prices. Keith also cut out a second piece which will be a top support and that'll get attached to the main upright. He's cleaning them up on the awesome new Brodbeck grinder, which I'm really enjoying, with lots of accessories, making it super versatile. We need to drill a couple of holes, one for attaching a table and the other for a bushing which will carry a shaft from the motor. This is how the pieces will be arranged, and we turn this other piece off camera, which will be a boss on the back of the upright, and next I'll weld that piece on. Next we put it in the 4-jaw chuck on the lathe and set about machining it. It doesn't look like we're doing anything here, but we are cleaning up the whole face of the upright. We didn't completely clean up my welds, but a bit of filler here and there when we come to paint it, and you'd never know. Next we bored it out to the final dimension, ready for a bushing. Now that all the pieces for the body have been prepared, I'll weld them together. I've added a bit of extra weld on the side so we can sculpt them later on and make nice transitions. That was the end of the first day, so the next morning Keith took it into the grinding room and started to shape and refine it. Next I'll glue the column section into the cast base, and to do that I'll use Loctite. The pieces are a great fit, so this should glue together very well. While that's setting, we'll start working on the flywheel, which we turned from a piece of EN26 steel. We'll cut a decent chamfer on the back of the flywheel to give it some clearance as it gets close to the weld fillets on the body. We need to add a dowel pin to the flywheel that's off-center. This will create a cam and drive the main vertical shaft up and down. I'm using one of Corin's awesome carbide center punches. We used heaps of his handmade tools in this project, as I do in most projects. I'll put a link in the description if you'd like to check out his website and his full range of tools, and if you'd like to support him. After drilling the flywheel, I then reamed it, but this cheap reamer ended up being oversized. So we took the Niroc carbide center punch, and Niroc is Corin backwards by the way, and created divots all the way around the pin. There's no way a regular center punch would do this, or at least it wouldn't without any damage, as the pin is hardened steel. We did get a bit ahead of ourselves there, as the pin is too long and it needed cutting down to length, but we let that set and then we cut it down off camera. Next we'll glue in the drive shaft, which is made of silver steel, and fortunately the reamer for this worked very well and it was a good fit. Next, we'll make this pot that clamps to the main shaft. It needs to be 18mm thick. I don't have any flat material that thick, so we'll take a slice off this 50 by 50mm square bar. We'll shape the outside later on, but first we'll face up this edge and cut a slot. A square nut that will sit on the pin of the flywheel will also slide in this slot, and that will transfer into an up and down motion. I'm drilling all the way through the clamping section with a tap drill. Then after tapping the threads, I'll go back and drill out the threads on one side for the bolt to pass through. That's the clamping piece done, so now we'll make the main bushing from a piece of bronze bar stock. We don't need any glue here, we'll press it in as it's a super tight interference fit. That went well, so next we'll bore out for the vertical bushings. We've indicated a horizontal shaft across the top and the side, so we're confident that the bores that we're about to drill will be perpendicular. The drill bits are just about long enough, and drilling both holes now after it's been welded together ensures that they'll line up. We're going through with increasing size drill bits, and the final size will be 18mm. And here's the bronze bushings ready to glue in. We left those to set while we had lunch and then came back and drilled them while it's in the same position. That's just about perfect, but the one thing that we did forget to do though was drilling mounting holes in the base. We were supposed to do that before gluing on the base, and now it's going to be difficult to access. First we need to machine a flat, but I don't have an end mill long enough, so we've ground this old cheap drill bit and see if that will work. We need a flat for mounting the screws to sit against and also to help drill the holes. It's deflecting a little and it's not perfect, but it is working and it's getting the job done. We milled the flat again after drilling the hole, and the modified drill bit was a lot happier with the centre gone where we drilled the hole.
So much better.
We did the other two off camera, so next we'll make the cam nut and we'll do that from bronze. Once more, there you go, that's it. That's all the parts that we need to try out the mechanism. I'll quickly assemble it and power it with a cordless drill. That's okay. Yeah. That was amazing and it looks like it's going to work well. Next we'll make the table, and again we'll use a dumbbell weight as I really want a cast iron top. Corin turned a shoulder on it so we could mount it better in the chuck, but first he decided to remove the bulk of the material on the belt grinder before machining it. After boring it out, we machined a recess for an insert to fit into. That came out amazing. Off camera, Corin turned off the lettering underneath. It's the end of day 2, so I painted the underside of the table, the body and the clamping piece so they can dry overnight. The first coat dried in about 15 minutes, so I filled it with 2-part filler, sanded it back and put a couple more coats on. Next we'll make a bracket from this angle to attach the table to the die filer body. We're actually still on day 2. We've decided to go back into the workshop after dinner and do a bit more. Here we're shaping the bracket to fit the underside of the table. We've got the small wheel attachment set up on the belt grinder and cleaning up the bracket. To mount it to the table, we'll use 4 bolts. We'll drill through holes in the bracket, transfer those onto the table, and then drill and tap them. It would have been easier to drill all the way through and just use nuts with countersink bolts, but this will be much nicer. We did 2 holes first, bolted it in, and then transferred the other 2 holes. It's all starting to come together. Next we'll make an insert for the table. I'm looking through all these cast pieces left over from an old broken lathe for something suitable. The next piece is a wiper on the top bushing to help prevent filings from getting in there. We'll make an oversized guard from brass with a single mounting hole and then an insert from Delrin that will fit against the shaft. Corin came up with a clever idea to use the burr left over from parting off the insert, and we'll use that as the wiper, and this was the reason for using Delrin in the first place. We're starting to get close, so next we'll make a pulley from aluminium that will be belt driven from the motor. And here's how we're going to power it. A sewing machine motor. It's already variable speed, which will be perfect. We're not 100% how well it will perform, but we're pretty confident. We've ground the form tool to match the pulley on the motor, so next we'll cut a groove in our pulley. That's the pulley done, so next we'll drill the end of the vertical shaft to accept a file. We'll then drill and tap through the sides of the shaft for grub screws to hold the file in place. We're moving along quickly now as Corin and Keith want to see it running before they leave. Anyway, the next part is an aluminium block for mounting the motor to a board, which I'll prepare next. It's a piece of reclaimed silky oak. I won't do anything special, just clean it up a bit, add some filler and put some oil on. While I'm at it, I'm preparing a couple more boards for Corin that he'll use to display his tools when he's selling them at shows. That's almost all the parts. We just need some mounting screws. These stainless steel lag bolts will work, but I'd like the heads to be domed and slotted, which will suit the machine much better. So now the exciting part, putting it all together. We made a couple of bronze washers off camera. You can see one of them here already on the back of the flywheel. I also remade the bronze nut as the first one wasn't quite long enough. We haven't ground a flat on the shaft, but we'll see if the pulley slips, and I can do that afterwards if needed. We need to cut and join the poly belt. None of us have done this before, but it was actually very easy. That looks like it's going to work with plenty of control of the speed, and it's not jumping around all over the place. I didn't show it earlier, but you can see that we drilled and tapped holes in the shaft at 2 different heights. This should allow us to make fine adjustments to square up the file to the table. The files for this need to be parallel, so to start we'll use a chainsaw file, which is the perfect size. We'll mount it from the tip so the files are cut in on the downward stroke, and again the chainsaw file tip is the perfect size. It's ready to go, and Keith jumped in there first. We'll cut the file down next, and then Corin can have a go.
Don't do much.
It's working great, and that's a fairly fine file. Anyway, it was all a bit of a rush at the end, and the guys have now left. I've got a couple of things left to finish. I rotated the shaft 45 degrees, so now I can access all 4 grub screws. The way it was, the one at the back was difficult to get to. And I also made this top hat off camera. The original die filers had a piece like this, but they were used to hold the file in place. I didn't realise that it also deflected filings away from the shaft, so I decided to make one. To prevent the table from rusting, I put Boeshield T9 on, which works amazingly well, so now it's time for me to give it a go. It's a great little machine and it's super fun. I need to make some other files fit as well, and I have a plan how to make that happen. I'll cut this square file down first and then I'll show you the setup. I've drilled a through hole and turned down this bar with a slight shoulder. It just about fits through a collet block, and the shoulder is enough to stop it from going all the way through. I then made a collet out of Delrin to hold the file in an ER collet. I'll hold the shaft in a vise, and then I'll be able to spin the collet block with the file to grind a tang on it. That worked out great, so let's put it in and give it a go. I still need to get more files, a triangular one and also a few with safety edges ground on. I tighten the grub screws, then back them off just a touch. Then with a 1, 2, 3 block, I tighten them again, making sure to keep it square to the table. It worked perfectly and it was super easy to do. I'll try it with a piece of steel. It's a bit thicker as well, and I'll try and square up this hole. And this is the kind of task that I imagine that I'll use it for. I'll do a quick test on the brass just to see how well the coarse file works. And that really does work very well, so I need some coarse files and some fine files. Anyway, it was a super fun build. A big thanks to Corin and Keith for an awesome few days and for all their help. Hopefully you enjoyed the video. Thanks for watching, and I'll see you on the next one.